In this tutorial, we will be discussing percent composition. This is also known as the mass percent composition. It's the element's percentage of the total mass of the compound. So here we're taking the mass of a sample compound, mass of one element of the compound, over the entire compound times 100. So for instance, we have a question here. A 0.358 gram sample of chromium reacts with oxygen to form 0.523 grams of the metal oxide, so of the whole thing. So the 0.523 is of the whole compound, whereas the 0.358 is of just chromium. So in order to figure out the mass percent here, what we're going to have to do is figure out how much of the whole thing is just chromium. So we have 0.358 grams of chromium over 0.523 grams of the total, the metal oxide, times 100. And that comes out to be 68.5%. So what the mass percent is telling us is of the entire compound, 68.5% of it is coming from just the chromium. We can use mass percent composition as a conversion factor between the grams of the constituent element of the specific element to the entire compound. For instance, here in sodium chloride, 39% of the sodium chloride is coming from the sodium, which means out of 100 grams of sodium chloride, 39 of it is coming from sodium. We can then use this as a conversion factor. Here's like a real life question. The FDA recommends that adults consume less than 2.4 grams of sodium a day. How many grams of sodium chloride can you consume and still be within the FDA guidelines? Knowing that 39% of the mass of sodium chloride is coming from sodium. So that means 39 grams of sodium are in 100 grams of sodium chloride. So 2.4 grams of just the sodium. Sodium's on the top, that means we want to put it on the bottom of the next one. 39 grams of sodium is equal to 100 grams of NaCl. So 2.4 times 100 divided by 39. That comes out to be 6.15 grams. So that means you can eat 6.15 grams of NaCl before getting to the maximum amount of sodium you're allowed to have in a day. Several questions that you'll have might just simply ask for the percent composition. When they ask for this, they're asking for the percentage of both the hydrogen and the oxygen of the compound. So before we begin, we need to figure out what the mass is of all of this. So we have hydrogen and oxygen. 2 hydrogens, 1 oxygen. Look on the periodic table, you can see that hydrogen is 1.0 and oxygen is 16.0. Add those together to be 18. So that's the mass of 100 grams. That's the mass of 1 mole of water. So we want to know what the percentage of hydrogen's in there and the percentage of oxygen. So out of all of this, 2 grams of it is hydrogen. So we're going to take 2 for the hydrogen divided by the total times 100. That comes out to be 11% hydrogen. Now we can do the same thing for oxygen. 16.0 grams from the mass of the oxygen over 18.0 grams from the mass of the water times 100. That comes out to be 89% for oxygen. Another way you could have done this is once you solve for the hydrogen, you can do 100 minus 11, and that would still give you 89%. Because they have to add up to 100%. Alright, so here's one that's a little bit longer. The percentage of sugar, C6H12O6. We have 3 elements here, carbon, hydrogen, and oxygen. We have 6 carbons, 12 hydrogens, and 6 oxygens. So the carbon is 12.0, which is right here. The hydrogen is right here, 1.0. And then the oxygen is 16.0. Multiply that across, and that comes out to be 72.0 for the carbon, 12.0 for the hydrogen, and then 96.0 for the oxygen. Add that all together and we get 180 grams for the whole thing. So if we look at just the carbon, we see that 72.0 divided by 180.0 times 100 comes out to be 40%. So out of this whole compound, 40% of its mass is coming from carbon. We can do the same thing for hydrogen. 12.0 grams over 180 grams times 100 comes out to be 6.7. And finally we have oxygen. I'm going to put that one at the top because I'm running out of room. So the percentage of oxygen is equal to 96.0 over 180 times 100. And that comes out to be 53.3%. All three of these numbers, the 53.3, 40, and 6.7, should all add up to 100%. Sometimes you'll be asked about just one of the elements. So here, what is the percentage of just the copper? You still have to figure out the mass of the entire thing in order to figure out the mass of the copper. So here we have copper, phosphorus, and oxygen. 3 coppers. We actually have 2 phosphorus and 8 oxygens. So looking at our periodic table, we find that copper is 63.5. Phosphorus, which is right here, is 31.0. And oxygen, which is right here, is 16.0. We want to multiply that all out. Copper comes out to be 190.5. Phosphorus comes out to be 62. And oxygen comes out to be 128. Add all of that together, and you get 380.5. Now we just care about the copper in this question. So we just want the 190.5. Divided by the total, which is 380. Multiply that out, and it says 50.1% of the mass of copper phosphate is coming from the copper. And that is how you do percent composition.